Hi, my name is Mia Baden, and today we'll be talking about machine learning. In this day and age, data is everything. Machine learning is what people rely on. According to May 2020 on the World Economic Forum, a well-educated and well-reputed business magazine, Klaviyo has launched a chatbot to make it easier for people to find official government communications about COVID-19 and using machine learning. During this time, while having so much information, using this information to make the right decision is everything. With such a vast audience here in the class, it might be possible that some of us students are not familiar with the concept of highly trained machines capable of making decisions by themselves except in movies. Machine learning is utilizing data and running them through different models of data analysis to make predictions. It is using our YouTube recommendations, Googling results, and Zoom backgrounds. I did a machine learning startup in the summer focusing on diagnosing people with coronavirus using a medical data set called Informatica and running them through different machine learning algorithms. In this speech, I will explain particular types of machine learning concepts and their applications. We will be explaining 3 types of machine learning categories: supervised, unsupervised, and deep learning. Supervised is one of the types of machine learning. There are 2 types of supervised machine learning: classification and regression, and they're used differently. Classification algorithm is classifying objects using common similarities and differences. A simple example of classification is all turtles have a shell and a bird has its wings. So, for example, if it has a shell, then it'd be a turtle. If it has wings, it'd be a bird. If you have multiple questions, for example, when you're classifying whether or not an animal is a reptile or a mammal, the question would be whether or not it has eggs. True and false. And then from the mammals, we can have another question. Does it have wings? If it is, it's a bat. And if it's not, it's another animal. And then we can have these types of questions. And that's a type of classification. Another example is using machine learning in Gmail's algorithm to classify mail with social updates in primary. Primary is an email for contacts. Social is for networks like Twitter, Facebook, YouTube, SoundCloud, etc. And updates are for bills, receipts, and confirmation emails. So if it has a charge to it, then, for example, if it says an update your account, then it would be definitely either the updates or the social. The updates or possibly the primary, I don't know. And then for example, if it had "Dear Rebecca, how are you?" and it's an email that you've already have in your contacts, then it would definitely be a social. Another area of machine learning is regression algorithms. Linear regression, if you have ever seen a graph of an average kid's growth, the average trend line of this type of graph is called a regression line. The regression line is important because it can classify objects based on whether or not they lie above or below the regression line. So if you have mice and they're this height, you can figure out whether or not obese or not by determining whether or not they lie above or below the regression line based on height and weight. When we're dealing with data that doesn't been classified yet, we also have tools that let machines classify the data itself with unsupervised learning. There are 2 types of unsupervised learning: principal component and cluster analysis. If you have been in an airplane at night, you might notice that each city looks like a small circle of lights, and there are like bright spots on a mostly pitch black ground. A city is a cluster of lights. A computer can compute the distance between the lights and detect whether it's a cluster or city. So this one's a cluster based on the fact that it has more density of lights. So the computer algorithm, in a similar sense, can determine this is the cluster because it's a very dense amount of things packed into one area. This one's also a cluster as well. All data can be translated into a graph, for example, on a two-dimensional graph of height and weight. However, if you had hundreds of variables, well, do you have to create a 100-dimensional graph? Principal component analysis uses matrices to condense the dimensions to make it easier to classify data that is on a high dimension and group them together. So for example, this is on a 3-dimensional plane, and using matrix transformation, PCAs will allow us to see it in a 2-dimensional graph and see the clustering in this way. This is usually used when you have multiple, this is for genes, genetics. If you have a high variance of this type of specific gene, and if you have this variance of this specific gene, you can figure out that these genes have this high concentration of this and high concentration of this and categorize them. All these methods can possibly solve most of any problem that requires machine learning. However, some problems do require a more complex algorithm. Deep learning is a software that mimics a network of neurons in the brain. They enable us to cover most of the complex problems we face in the current era of machine learning. There are 2 types of neural networks, shallow and deep neural networks. They're based on how many filters each neural network requires. A shallow neural networks are simpler and more understood neural network. The idea of how these machines work is that as a data set of usually numbers will go through a hidden layer known as a convolutional layer of a neuron to have our mechanical brain learn concepts. So in the same way, if you have a eraser and your brain detects it, there's a lot of calculations that are happening in the brain, and we return the answer pink. In the same way, a neuron has a input, and in between there is a function that will turn it and turns it into an answer. And this is shown in the graph of a convolutional neural network, which is these types of things have a certain function or a mathematical function related to them. We're not exactly sure because they are generated, and from the input to this output, there's some output, there's something in between that enables us to get the outcome. So computer vision plays with the same idea, but rather than numerical data set, we're working with 2 dimensions. Each pixel in the computer can be represented with a 2D matrix. Each pixel can be fitted through a filter. For example, a filter that only takes vertical lines and one that takes horizontal lines. For example, this would be a vertical, this would be a horizontal line. And the combination of 2 filters would reveal edges on the computer. So if this is so imagine you have also other ones that detect a curve, maybe a like translational, like a sideline, and maybe even something does the opposite, like the line that goes this way. And you finally, so one of the 2 filters that would be shown are these. So the vertical filter, and this is a horizontal filter, it'll capture the vertical lines on this graph. And this one horizontal would be capture the horizontal lines on this graph. So they would reveal edges to the computer, and because you simplify the picture into horizontal and vertical lines, the machine would be able to easily detect it. And in this way, more and more lines and complexities are revealed to the computer. The computer, through increase in filters, starts detecting lines, edges, vertices, curves, then finally some shapes. So these are a combination of probably hundreds of filters. And after having the compilation of filters go through many, this is what the computer sees. They can compare shapes, and they can be detected to other images, and the machine can recognize and finally detect an entire object and labels it as the objects. So at this, the machine could possibly detect it as a road after going through many filters. Now that we have examined multiple types of machine learning algorithms, let me summarize some of the things that I've explained. Once again, when it comes to applying machine learning to a data set, there are many types of strategies we can utilize to best predict the outcome of a problem. Important and really popular strategies include supervised, unsupervised, and deep learning. And as we look closer to 2020, I ask, can this be the year when the matrix comes real? Thank you so much. These are my sources right here. Thank you so much. Have a nice day. Bye-bye.